Good morning, everybody. Thanks for coming to the FluidMesh press conference. So today we will be talking about the history of FluidMesh. I would like to give you a little bit an overview on our story. This is our 10th year anniversary, and so we are here also to celebrate 10 years of success in wireless and wireless connectivity. But also I'd like to show you what we believe the future of FluidMesh will be and talk about the Internet of Things. The Internet of Things is for us a fantastic opportunity. We build networking products, we build wireless connectivity solutions, and so the Internet of Things is a great opportunity because it's going to create a requirement for a lot of networking, and so that's why we're so excited about it, and we want to tell you about it today in our press conference. So my name is Umberto Malesci, and I'm the CEO and co-founder of FluidMesh. So it has been 10 exciting years for us. As many of you know, the business was started by 4 people. 2 of us were from MIT in Boston, the other 2 from the Politecnico of Milan. So 4 engineers started this business, really started while we were still researchers and students. And we're very proud that we've been able to build a business that after 10 years is still around and is still paying and many people and making their living successful and possible. So we went from 4 guys to a global organization. We are right now in many different countries. We have our headquarters in Chicago. We just opened a new office in New York City to provide a better support to our East Coast customers that are many. It's a very active territory for us. We have our R&D team and technology development team in Milan, now in a new office in Italy in Pisa, and in our office in Taipei. And then we have sales offices in Latin America, in Lima, Peru, and in Paris and London to cover the European market. So right now we have more than 1,000 resellers across the globe, and presence and deployments in more than 75 different countries. So just as a small joke, I'd like to show you the evolution of our product in the past 10 years. So let's start from the human evolution and let's jump on the FluidMesh evolution. We started from a bulky product with 2 radios, the FluidMesh 2200, initially called VideoMesh 2200. In 2005, was very successful. We had many successful deployments with that product. Then we went to smaller form factor. We moved from external antenna to integrated antenna into the enclosure. We have the FluidMesh 1100, the FluidMesh 3100, the 3100 Mito, and then the Volo product, the 1200 Volo that is currently on the market and has been definitely our best seller in our history. And then the new 3200 base and the 4200 Mobi for mobile application, certified for railways deployments on board, on trains and trackside deployments as well. So we wanted to provide you an idea of how many wireless links, how many different places we've been connecting. So we try to run this exercise. So we look at our sales in the different years, and in 2005 we essentially didn't sell many links, wireless links at all. We sold a wireless link of approximately 1.5 miles, just essentially the distance of the Golden Gate Bridge. But we move forward, the company has been growing in the past 10 years. In 2006, we've been able to sell 80 miles worth of wireless links. That essentially is the distance of 20 times the Sunset Strip here in Vegas. In 2007, we did 300 miles of wireless links. So essentially the distance from here, from Vegas to San Diego in California. So recently, in 2014, we sold more than 7,000 miles of wireless link. That makes the distance from here to the South Pole. So in the past 10 years, we sold 24,000 miles of wireless links. Essentially, we've been able to go around the world with as many links we have sold. Pretty exciting, to put them one after the other and get an understanding, a more physical understanding of what we've been able to do in the past 10 years. So where we're going next? Clearly, we're going to the moon. That's very easy. 162,000 miles that we missed to get to the moon. And what is the moon? And now this gets on the interesting portion of this presentation. The moon for us, we believe, is the Internet of Things. We believe that it's the Internet of Things because it's a massive opportunity. It's a massive opportunity for the IT industry, for the networking industry in total. But let's start understanding what the Internet of Things is. So I'd like to start from this graph. This is a graph that shows the amount of searches on Google for the term Internet of Things. So clearly there are many people that don't know what the Internet of Things is, but who are very interested in understanding and learning about the Internet of Things. You see how in 2008, 2009, people in companies like us, in networking companies, we were already talking about the Internet of Things. It was starting to be a topic of discussion, but definitely it was not something that the mass market was aware of. Right now, it really went up exponentially, the number of people that are searching on Google the term Internet of Things, and they're trying to understand what the Internet of Things is. So, in a diagram, what the Internet of Things is are connected devices that are able to make intelligent things because they are connected to each other. So we go from very straightforward applications of this well-known, smart fridge. Everybody talks about the smart fridge, the fridge that is connected to the network and is able to automatically order grocery store at the grocery store and get them delivered. So you get the fridge replenished. That's everybody talks about it. But let me give you a more specific example of the Internet of Things. For example, if we take a smart city environment, a urban environment, Fluidmesh works a lot with smart cities in urban settings. So there are some research that shows that 30% of the traffic in a urban area, in a city, are due to people looking for a parking spot. So when the Internet of Things will be a reality and will be deployed and leveraged its full potential, we won't be spending 30% of our time looking for a parking spot. We will know exactly where a parking spot available is, and we will just drive there because we will be guided. And ideally, we won't even need to drive the car because the car will drive itself to the available parking spot. So the same research says that on average we spend 20 minutes a day looking for a parking spot. So imagine the huge efficiency that you have just by putting sensors in a city and letting people know on their smartphone, on their smart device, on their vehicle, where the closest parking spot available is and where they should drive. You don't stay around in a neighborhood looking for a spot. A similar example could be from the aviation industry. On every large aircraft, on any airliner, you have many different sensors. A very important sensor is a weather radar that is able to scan the weather in front of the aircraft and look at clouds, and is able to have a 3D imaging of the cloud. This 3D image of the cloud is provided to the pilot, who right now is the only user of that image. With the Internet of Things, we will be able to download that image from the aircraft to the ground, and we are going to be able to put that image together with all the other images coming from all the other thousands of aircraft around the globe that are traveling at any point of time. So it will be like having thousands of sensors, of radar sensors, airborne radar sensors collected to each other. This will give us an amazing amount of information that we will be able to use to better predict the weather. And weather prediction means a lot a lot of money, means be able to better predict the outcome of a crop, means better air travel, means safer air travel, for example. It has an amazing impact. So you understand how networking and sensors connected to each other are able to make our life better, and why there are billions of dollars worth of value into the Internet of Things. Just showing you this example from very different industry, from the city, the traffic issue, to the air travel issue. So this is a diagram coming from a Goldman Sachs report of their equity team. It shows the size of the Internet of Things market in terms of devices. Now here we see years, and on the x-axis and on the y-axis we see the number of connected Ethernet ports, connected devices. So you see the gray line shows you the PCs, so the wired connections. We went from the mid-90s to a little more than 60 million devices to right now where we have 1 billion devices connected. And you see how faster is the growth of mobile devices, the light blue line. We went from 2007, 100 million connected smartphones to 6 billion expected by 2020. So we already have an order of magnitude difference between smartphones and connected PCs. And then when we see the dark blue line, from 6 billion to 28 billion devices. And this is the Internet of Things. This is why we're excited, because we're talking about another quantum leap in number of devices connected. So you can imagine that these devices, to be connected to all those smart things we were talking about, require a reliable network infrastructure. And a lot of this network, as we will see in a second, is actually wireless. So what is making the Internet of Things possible? So one is the drop in the cost of compute. Computational costs went down dramatically. You see in this graph that goes from the early 90s to 2013 that the cost for 1 million transistors went from $500 to 5 cents. And then on the right, we see the cost of bandwidth. Also, the cost of bandwidth dropped dramatically. So 100 megabit per second went from more than $1,000 to $16. So I like this definition. This definition comes from a Goldman Sachs report as well on the Internet of Things. They try to define, to create a perimeter of what the Internet of Things is. So an application to be classified, considered an IoT application, what kind of attributes it must have. So it must be sensing. So sensors are a critical component, and cameras, Fluidmesh works a lot with cameras and video sensors, are a critical component into this equation. So video sensor, temperature sensor, acceleration. We were talking about a weather radar. A weather radar is a sensor. So all these are the edge devices, the sensing devices. So to be IoT, it needs to be efficient. We need to be able to be efficient in terms of power consumption, because some of these devices might be remote in the field, and so power can be extremely expensive. It clearly needs to be networked. These sensors need to be connected to each other, need to be to transmit the information. So we already have the sensor on the aircraft, the radar sensor, but now it's not networked. So it's not IoT. As we network it, it becomes IoT. Similarly, we already have sometimes sensors to tell us if the parking lot is available, or maybe we might have a camera right in front of our parking space, but that camera is not connected to a network and then goes to the cloud device. So it's not IoT. It will become IoT. It needs to be specialized. So IoT really covers many different vertical markets, but each specific application that creates value, it's vertical specific. So I showed you smart cities, I showed you aviation, I can show you security, different specialized vertical applications. And then it's everywhere. It's everywhere because it's pervasive. It's in our vehicle, it's in our smartphone, it's in our aircraft, it's in our trains, it's in all our devices. It goes from the fridge to the aerospace industry. So this is the landscape. We go from the wearable devices that are having an amazing traction right now to connected vehicle, to connected cars. Then we go to the home environment. Connected home, we've seen many opportunity in connected home, from smart thermostat to many other appliances that makes our home smarter, up to the fridge that will order groceries online. And then the connected cities, the smart cities. This is an area where Fluidmesh has been extremely active, and I wanted to show you the example of the smart city because it's very important. And then even larger areas, so large infrastructure, transportation. We've been very involved with railroads, automating and making them more efficient. We're talking about trains that passenger trains that are able themselves to detect if the track that they're using is fine or if it needs to be it requires some repair. So they have laser sensor underneath that check as the train travels and bring hundreds of passengers around. They check that if the track is perfect or if it needs to require some changes. Industrial Internet, this is a term created by General Electric. They're very active in the IoT as well, and that's definitely an area where there is a great opportunity to add sensors, make our industrial plants more effective, more efficient, more connected. So let's take a look at the structure of the Internet of Things. So we have an application layer that typically runs in the cloud. It's a cloud application and it's a web application. Then on the other hand, we have the IoT sensors. So we mentioned could be a camera, could be a temperature sensor, could be a thermostat, it could be a radar, it could be a sensor that tells you if a parking lot is used or not. It could be a sensor that tells you if a toilet on a train it's damaged or is working properly, if it's out of order or it's working properly. So these two the sensors and the application layer are connected to a network. Typically the network, there is a core that is wired, and then there is an access component of the network that is wireless. And that's where Fluidmesh fits in and why we are so excited about the Internet of Things, because it requires a lot of access, and all the access is provided through wireless network. Now let's get in and look at the details. So here we see the vertical markets we just mentioned. We go from the wearables to the homes, to the vehicles, smart cities, transportation, rail, trucks and logistics, and industrial side. And then there are vertically specialized modules, embedded modules that can help connect all those sensors. So I wanted to go from those very high level, 40,000 feet perspective, provided a lot of it was coming from a Goldman Sachs report, as I said, to a slide coming directly from our sales presentation of our product. Here we show some of the applications that we typically describe as typical devices that gets connected to our wireless networks. And this was designed well, this presentation is there, and this slide was designed well before all these people were talking about the Internet of Things. So Fluidmesh has been doing the Internet of Things for the past 10 years, well before everybody brought this term around and went around talking about the Internet of Things. It's really what connects all the different vertical market that goes from video camera to thermal imagers to radar to audio to enterprise backhaul to access point for Wi-Fi to access control to automation in industrial side. What gets everything connected? These are Internet of Things applications. And we've been doing this for the past 10 years. So we believe that the Internet of Things is the future because there is a tremendous opportunity for growth, but we are already expert in the Internet of Things because we've been doing it for the past 10 years. And now I'd like to show you some additional applications of what we do and how much these are connected to the Internet of Things. So our mobile division is very much involved in IoT applications as well. We go from connected vehicles, we're doing connected vehicles for police departments across the globe, streaming data and video streaming from the vehicle while they're driving around. On the right, we see connected vessels, like the waterways project I'll tell you in a bit, where we connected a fleet of ferries across the Hudson River in New York City. And then you have logistics and industrial automation, crane automation, and connected harbors. And then on the bottom right corner, railroads and mass transit, so connected vehicles in the mass transit industry, making rail smart, so the so-called smart rail projects. So this is all coming from our marketing material, and you see how there is a perfect match between the 40,000 feet view of the Internet of Things provided by one of the largest institutional investors in the world to what Fluid Mesh enables every day, because Fluid Mesh is really, as a networking company, is an enabler for the IoT world. I'd like to tell you about some of the projects that we already have done that are IoT projects, because I have sort of the impression that many people believe that IoT is going to be the future, and definitely I agree it's going to be an amazing and bright future for many companies like us. But IoT applications have been around for quite a bit of time, although they had different names. Nobody was talking about IoT 5 or 6 or 7 years ago, but we were doing it. So I'd like to show you a specific example in different vertical markets we've been very active in. Going from smart cities to industrial harbors, I want to show you some mining applications, railroads, and mass transit. And you will see how these vertical markets tend to have similar horizontal application of IoT technologies and sensors. And you will see how, like, for example, video streaming tends to be in common of many of these. Vehicle automation is in common for many of things, in many of these areas as well, for example, and video, mobile video as well. Let's start with urban video surveillance. This has been our core market, our core competence center as well. We've done many cities around the globe, going from city of Chicago to city of Charlotte, city of Vancouver, the city of Milan in Italy, many cities in Europe, Birmingham, in the UK, so a large number of different deployments around the globe where we've been using our wireless technology to connect video sensors, cameras, typically for security related applications. These are typical smart city applications, and definitely they are IoT applications. We were talking about urban video surveillance in the past 10 years, but it's actually a very important segment of IoT. Public addressing, we recently have done a project in the UK where we cover a large area. It's actually it's a military site, a urban area, but it's a military site of the Royal Navy, with our radios to provide a medium to transmit audio across this large area. So you see how one single wireless network can help not only for video streaming but also for audio streaming. You have the typical IoT, two-way incoming video, and then you process the video manually or automatically in the cloud, and then you can transmit data, in this case voice, outside to inform people what they're supposed to do. Let's look now at the port vertical market. Ports has been a very successful segment for us. One of the first projects we've done back in 2006 was the industrial harbor of Marghera in Italy, right in front of the city of Venice. They required cameras for security applications, and we have been able to build a very reliable, redundant wireless network in the port to stream that video from different pretty remote locations on the waterways. We've done many other ports. We've done many ports in the US, including Port of New Orleans, Port Fourchon in Texas. We've done many ports also in Australia, like Port of Melbourne. So we've been successful in security in ports because they're challenging environments where you need a wireless network to stream all that video in different locations. But there is another interesting component in ports that has to do with automation. So we're now getting more and more involved in automated ports where they have automation devices and vehicles that move around, for example, containers in an autonomous manner. and they clearly need a wireless connectivity to stream data from their sensors and to get commands from the central control center. And crane automation as well has been an area where we've been very active in ports, industrial harbors, but also in rail yards and intermodal yards, as I'll show you in a second. And then in ports, there is also the vessel connectivity and the port connectivity portion. We've done an amazing project in New York City covering with base station the entire Hudson River and East River to provide live, continuous connectivity to the New York waterways vessels that are a ferry system that connects the New Jersey shore with the Manhattan shore. And they had cameras on board, they wanted to provide Wi-Fi to their passengers, and they wanted to provide information to their passengers with infotainment. They wanted to be able to talk, use a wireless connectivity to communicate with the crew of the vessel. And also they wanted to get live information from the sensors on the vessels in the main control room to know if something was wrong, to perform predictive maintenance of the vessel, for example. This is a perfect example of IoT applications applied to a very challenging environment on water in a very dense urban area like New York City. Let's move to mines. In the past 10 years, we've done many mining projects, a lot of camera projects for security and safety applications. Video sensors and cameras are very useful to get video streams and check if there are challenges in a very sensitive area like a mine. The risk level in mining is very high, and people want to make sure that employees follow the right policies, for example, and typically video sensors help the safety policy enforcement by the mining management and help saving lives in this way. For example, we've done the Usibelli coal mine in Alaska. We've done a lot of mining in Colombia and in other countries in Latin America as well. Now we're moving into mining automation. Mines actually are pretty advanced compared to other areas in automating their tracks and in streaming data to and from the track in real time. It's a challenging environment because there are large areas where typically there is no cellular coverage, so cellular technology cannot be used. So Fluid Mesh is a great fit because we can cover with our base station the very large area of the mine. We can power the wireless devices through solar panel and batteries, and we can have connected vehicles in a pretty short amount of time, leveraging also the mesh capabilities of our radios. And clearly, vehicle automation in mining means efficiency, means saving time, and saving time means saving millions of dollars. Let's look at transportation, particularly railroads. So we started working with railroads, working with the big freight railroads in the US to help them put cameras in their rail yard and intermodal yards. Also in rail yards and intermodal yards, the requirement is security, but also safety and enforcement of the safety policies and procedure of the company to save lives, because accidents are very common, unfortunately. So we build a wireless network across these large industrial site and intermodal yards to stream this live video in high resolution in real time. We then work with them on yard automation and particularly crane automation. Cranes have many sensors on board, and the large freight rail operators are increasing the number of sensors because they want to increase their efficiency and precision of these cranes. So for example, they're adding video sensors to improve the accuracy of container picking of their cranes, and then they try to remove the controller of the crane from the crane and put a remote controller. Everything can be accomplished through a reliable wireless network that can provide and enable automation of the crane and signaling to the crane. So this has been an area where we've been very much active in automation. And then clearly rail as a big component for passenger rail that require connectivity. People want to be connected. Right now there is a huge demand for Wi-Fi on board on passenger rail, and there are not many technologies around that can provide broadband on a high-speed moving train. Right now we're working on a project to show how our technology can perform on at 400 kilometers per hour, so 250 miles per hour on a stretch of approximately 7 kilometers of a high-speed rail line with a really advanced train system. This will change the user experience of passengers on high-speed rail because they will be able to enjoy the same passenger experience, the same user experience that they're typically used to when they're in their office, in their home, where they can download video from YouTube, where they can speak on Skype, and they will be able to do the same on their train, and this makes us very excited because the speed of these new high-speed trains going around in Europe and in Asia is amazing, and this is a tremendous business opportunity for Fluid Mesh to solve a real big problem in the railway industry. There is also live onboard video surveillance. This is getting a lot of traction on metro lines. Security is always a big concern on metro lines where there are many people, and also people mover in airports require onboard cameras, and right now onboard cameras on metro lines and people movers have been mainly used for forensic applications and investigations. So if something happened afterwards, I'll be able to figure out who did it. We are changing this, and we're going from forensic post-mortem analysis to live streaming of video so that people and law enforcement agency can do something to save people's lives and to avoid accident and incident rather than just to perform investigation at the end. And we're working with many metro projects and people movers around the world to automate their systems and allow them live streaming while the train is moving at high resolution. Another interesting application that has to do with bus fleets and also with rail is video and data offloading. So this is a challenging technical problem. A train and a bus right now is full of sensors. As we said, many of these are not always connected. So they store all this amount of data into some local storage. But then at night or at certain location, they'd like to offload all the data to the network so that data can go to the cloud, to the management software, and then can be processed. And so some interesting analysis and decision can be taken based on that data. Just to give you an idea, we have a client who is a passenger rail operator who had to hire people to just chase trains to download video from those trains when the police ask them for a piece of video because something happened on the train. So they have people with a car, employees with a car going after the train where there is the recording and jumping on the train at the station, getting out the hard drive, putting another hard drive in, and then jumping off the train at the following station. And then there is a second employee that goes around the car and picks up the guy. It's amazing, this can be easily achieved with that offloading system. Wi-Fi doesn't perform very well. It's not really designed for this data application to be efficient in terms of spectrum efficiency. We designed a specific algorithm to download all this video stream, and we're working on many different projects in this area with many mass transit agencies across the US and also in Europe that have this requirement of downloading an enormous amount of data from their fleets at night and then process this data. And then train automation. We see how we've seen automation in vessels, we've seen automation in trucks, in mining, and there is also the train automation. It's called CBTC, Communication-Based Train Control. These are the new automated trains that do not require any driver very often, and they're remotely controlled through wireless communication. And we're very much involved in many projects with the leading players in this space for automated train control on metro lines, underground, monorails, overground, and people movers in airports as well. So I hope the presentation was interesting. I really try to give you both the 40,000 feet perspective of what investors are looking at, what's interesting for the industry at large, and why we're excited as well about the Internet of Things, these 28 billion devices that will be connected. Just to give you an idea, all the large companies in the IT and networking space are extremely active and investing in this space. I'd like to invite you to visit, for example, Cisco website, Ericsson website, General Electric website. They all talk about the Internet of Things. Somebody talks about the Internet of Everything, somebody talks about Internet and societies, somebody talks about the industrial Internet. They're all different terms and jargon that means the Internet of Things. So all large players are extremely active in this area, and because there is a tremendous business opportunity. Fluidmesh, we've been an enabler of the Internet of Things. So after the 40,000 feet perspective, I've been glad to show you the real project we have done in the past 10 years, real active application of the IoT concepts that have been already implemented already on the ground around the world and have been deployed together with our resellers and customers. So Internet of Things is reality today. There are companies already have companies and already have deployed this kind of applications, and will be a tremendous growth opportunity for us and many of the other players of this industry down the line in the coming years. As we saw, the expectation is to go from 6 billion to 28 billion of connected devices, and the world will be a much easier world to live in, and a much more connected world. We're very excited that we will play a major role in this to make all this vision possible. Thank you very much. Feel free to contact me either by email or on Twitter if you have any question or you would like any further information. Thank you. Bye-bye.